Thank you for attending Rome's webinar. My name is Chris Bahar, and I'm an applications engineer at Rome Semiconductor. Today, I'd like to introduce our new BA8290 series of automotive op-amps, featuring the world's first noise-tolerant design. First, I'd like to start with our op-amp and comparator initiatives. The pie chart on the upper left shows our op-amp and comparator delivery record in 2016 and includes a breakdown by market segment. Rome shipped 543 million pieces last year. And as you can see, the consumer and automotive markets make up a large portion of these shipments. The figure at the bottom right shows examples of where our op-amps and comparators have been designed into an automotive system. They are used in a variety of areas, including the main inverter, power steering, engine control unit, and airbag control. Now let's talk about our newest op-amp lineup. These products feature superior noise immunity that suppresses output voltage fluctuation in all frequency bands to less than plus or minus 1%. In addition to this, the entire lineup is AEC-Q 100 qualified, ensuring automotive-grade reliability. Rome's integrated production system allows us to deliver stable, long-term supply, and this series is pin-compatible with industry-standard products in terms of both package and pin layout. Furthermore, since the basic specifications are maintained against conventional products, replacement is simple. The product lineup is listed in the table on the lower right for both dual-channel products, SOP8 and MSOP8 packages, and 4-channel models, SOP14 and SOP-B14 packages. Next, I'd like to share market information on why noise tolerance is important in automotive systems and how Rome is able to solve this problem with the development of its op-amps featuring superior EMI characteristics. In recent years, various systems have been rapidly advancing to improve energy savings, safety, and convenience in automobiles. This increased use of digital automotive electrical systems has created a growing demand for improved noise immunity. There are several sources of noise within vehicles. Please take a look at this figure. In the case of a conventional op-amp, noise from the sensor's output signal and the op-amp are amplified at the same time, which may cause the system to malfunction. However, when using Rome's new high noise tolerance op-amp, only the signal source is amplified, ensuring normal system operation. This is why Rome's new noise-tolerant op-amp is the preferred solution. This next slide shows a graph comparing Rome's new op-amps to conventional products. The values are based on ISO 11452-2 noise evaluation tests. The x-axis shows noise frequency and the y-axis shows the output voltage of the IC. With Rome's noise immunity and excellent EMI characteristics, the output voltage fluctuation from the ideal voltage, 5.6 volts, is much less than conventional products. Unlike general products A, B, C, and D, with fluctuations ranging from plus or minus 3.5% to plus or minus 10%, Rome's new product line limits the output fluctuation to less than plus or minus 1% across all frequency bands, eliminating the need for noise countermeasures. Today, we have prepared a demonstration showing the benefits of noise immunity with a robot arm demo. We prepared two ICs. The right side shows a conventional product, and the left side shows Rome's new IC. The robot arm begins to move when we insert the conventional IC into the board. When I move the radio transceiver or high noise source close to the IC, the robotic arm movement stops because of the part's low noise tolerance. Now, let's switch the IC to Rome's noise immune part. When I move the transceiver close to the IC again, the robot arm still moves because of our excellent noise tolerance. As you can see, having excellent EMI characteristics is advantageous. To achieve similar noise immunity in conventional op-amps, you would need to connect RC filters to all input, output, and power supply pins. However, using Rome's op-amps utilizing our new noise-tolerant design eliminates the need for RC filters, reducing up to 13 additional circuit components. But ultimately, one of the key benefits of this part is to reduce design load. The top figure represents the typical design flow using conventional op-amps. Typically in board design, noise countermeasures are implemented after the functional design is completed, but noise design can be difficult and time-consuming. If noise design is implemented incorrectly and the failures are not caught before the fab and evaluation step, the process will need to restart from the beginning. On the other hand, Rome's new product allows the design period to be significantly reduced by eliminating the need to implement noise countermeasures after the functional design step and significantly minimizing the risk of board failure due to noise when compared to conventional op-amps. So, as a result, our new noise-tolerant IC reduces design load and costs while enabling quicker development time to meet short delivery demands. So, how did Rome improve the noise immunity? Rome developed new noise countermeasure circuits that leverage Rome's proprietary analog design, industry-leading analog layout, and noise-resistant bipolar process technologies. Developing and implementing these three proprietary analog technologies allow us to achieve superior noise immunity. Now, let's discuss application examples. This is a diagram of the engine control unit. You can see the sensors on the left and a microcontroller in the middle. As I mentioned on a previous slide, op-amps are inserted between the sensors and the system in order to amplify the weak sensor output signals. Now, let's discuss the need to amplify sensor signals. Engine control units monitor a variety of systems, such as fuel level, temperature, and ambient conditions, by processing sensor signals using a microcontroller. The microcontroller receives sensor signals and then determines how to react. However, if you connect a sensor directly to the microcontroller, the sensor signal may be too small for the microcontroller to recognize. But by inserting an op-amp between the sensor and microcontroller, we can amplify the signal to support proper microcontroller operation. Sensor signal amplification is just one of the main uses of op-amps. Op-amps can also be used to monitor motor current. A current sense resistor is installed to calculate current by monitoring voltage. But to minimize power loss, this resistor often has low resistance and the resulting voltage difference between both ends is very small. Thus, the op-amp can be used to amplify the weak converted signal to a high enough level so it can be processed by a microcontroller. This system diagram shows op-amp usage in the main inverter of automotive systems to detect current. The right side of the system diagram shows the motor and the left side shows the microcontroller. Inserting an op-amp in between allows us to amplify the current sense voltage, allowing the microcontroller to detect the current passing through the motor. To detect current, Rome also offers ultra-low ohmic shunt resistors. Our new PSR series features high power delivery, 3 to 5 watts, and low resistance fluctuations, plus or minus 1% tolerance at ultra-low ohmic resistances. Additionally, these parts have a very low temperature coefficient of resistance to maintain resistance values over the 25 to 125 degrees C temperature range. Our broad portfolio of products gives us a competitive advantage, allowing us to propose complete solutions that combine ICs with discrete components to meet virtually any need. Finally, I'd like to end by sharing our op-amp product roadmap with you. The market demands improved noise immunity, high speed, high bandwidth, high accuracy, and low offset functions. And we are on target to expand our solutions into automotive, industrial, and medical markets. Developing these high noise tolerance op-amps is a good first step in achieving our goals. Thank you for joining us in this webinar. If you have any other questions about Rome's devices, please feel free to visit our website at www.rome.com.